Welcome to this comprehensive tutorial on data preprocessing. Whether you're a data science student or a seasoned professional, preparing your data is crucial. In this video, we'll explore the essential steps to ready your data for analysis, ensuring it's clean, transformed, and seamlessly integrated. We'll start by addressing common data issues and gradually move through each stage, from handling missing values to normalizing data, and finally combining data from multiple sources. You'll receive actionable techniques every step of the way. So, stay tuned as we delve into the importance of data preprocessing and how it sets the foundation for accurate and insightful analysis. Let's embark on this journey towards mastering your data. Before we dive into preprocessing techniques, it's essential to understand common issues you might encounter in raw data. Missing values can disrupt analysis and make datasets incomplete. Inconsistent data, with discrepancies in formats or naming conventions, can complicate the process. Outliers, those data points that deviate significantly from the norm, can skew results and mislead findings. Recognizing and addressing these issues is the foundational step toward effective data preprocessing. As we move forward, you'll see how to tackle each problem systematically, ensuring your data is clean, uniform, and reliable. The first step in data cleaning is handling missing values, a critical task to ensure the quality of our datasets. Identifying missing values is essential. By checking for absent data points, we can understand the scope of the issue. We'll delve into various techniques to handle missing data effectively. Imputation involves estimating and replacing the missing values based on the rest of the data, while deletion removes records with missing values if it doesn't significantly impact the dataset. Understanding these methods, their applications, and implications is fundamental for any data scientist. Next, we'll dive deeper into imputation, discussing specifics on how and when to use it effectively. Stay with us as we continue our journey through the essentials of data preprocessing. Next, let's tackle inconsistent data, a major roadblock for accurate analysis. We'll begin by identifying common inconsistencies in your dataset. This step helps you understand the scope and nature of the issues. Once identified, the next step is to standardize data formats, ensuring consistency and reliability for accurate analysis. Techniques such as normalization and type conversion play key roles in this process. By applying these techniques, you can transform an inconsistent dataset into one that aligns with your analytical needs. These are fundamental skills every data professional should master. As we move forward, you'll see how these techniques fit into the larger framework of data preprocessing. Stay tuned as we continue to explore the essential steps in data cleaning and preprocessing. Outliers can significantly skew your data analysis, leading to misleading results. Identifying them is the first crucial step, using statistical measures like standard deviation, z-scores, and visual tools such as box plots. Handling outliers is paramount to maintain data integrity. Techniques vary from simple removal to sophisticated methods like transformation or adjustments. Removing outliers may be more suited for large datasets, while transformations like log or square root can sometimes normalize extreme values. The goal is to cleanse your data without losing its essence. You'll see these techniques implemented practically so you can apply them effectively in your work. In this segment, we're delving into normalization, a key aspect of data transformation. Normalization ensures your data set is on a comparable scale, vital when working with varied data ranges. It's the process of adjusting values to a common scale without distorting differences in value ranges. We'll explore techniques like min-max scaling, adjusting values to a 0 to 1 range, and z-score normalization, transforming data to have a mean of 0 and a standard deviation of 1. Each technique has specific use cases and benefits. Understanding these will help you decide the best approach for your data. Mastering normalization ensures different features contribute equally to your analysis, leading to reliable results. Stay tuned. Categorical data, unlike numerical data, can't be used directly for analysis, but encoding transforms it into a suitable format for algorithms. Categorical variables, such as names, labels, or categories, can be converted into numerical values. Many machine learning models can't process string labels directly. Encoding converts these labels into numbers, making it easier for models to interpret. Techniques include one-hot encoding, creating binary columns for each category, and label encoding, assigning a unique number to each category. Understanding when and how to apply these techniques enhances your data preprocessing capabilities, ensuring categorical data is ready for analysis. Next, we'll dive into feature scaling techniques to ensure all features contribute equally. Stick around. In this segment, we're diving into feature scaling, crucial for data transformation. Feature scaling ensures all features contribute equally to the analysis. Without it, large-scale features could disproportionately impact the model, leading to skewed results. We'll explore standardization, transforming data to have a mean of 0 and a standard deviation of 1, useful for normally distributed data. We'll also examine min-max scaling, adjusting data to fit within a specific range, typically 0 to 1, handy for diverse value ranges. By applying these techniques, we level the playing field, allowing each feature to equally influence the outcome. Next, we'll delve into data integration and how to combine datasets from multiple sources effectively. Data integration is a critical step in preprocessing, enabling the combination of data from multiple sources into a cohesive dataset. However, it comes with challenges like mismatched formats, varying data structures, and redundant information. To navigate these, we can employ techniques like data merging, data concatenation, and ETL, extract, transform, load, processes. Each technique has its own advantages and is suitable for different scenarios, depending on your dataset's nature and requirements. As we explore these methods, you'll gain insights to tackle data integration challenges effectively. Next, we'll focus on ensuring data consistency throughout this process and how to achieve it seamlessly. Stay tuned. As we continue our journey through data preprocessing, we focus on integrating data consistently. When merging datasets, inconsistencies can arise, leading to unreliable analysis and skewed results. We'll explore techniques to maintain consistency, such as schema alignment and duplicate elimination. Each method harmonizes your data, safeguarding its integrity. By setting standard formats and ensuring alignment in data types and structures, you integrate smoothly, ensuring every piece of information aligns perfectly. We'll dive into these techniques in detail, giving you tools to maintain consistency in your integrated data. You'll see how these methods apply in real-world scenarios, enhancing your data analyses. We've journeyed through the essentials of data preprocessing, from resolving common data issues to mastering techniques like normalization and data integration. Each step is a crucial building block for making your data analysis more robust and reliable. Now, it's your turn to put these techniques into action. By applying the skills covered, you'll be prepared for any data challenges. To deepen your understanding, explore the resources listed in the description below. Whether you're a student, a data enthusiast, or a seasoned professional, continuous learning is key. Dive into these resources and take your data preprocessing capabilities to the next level. Thank you for joining us. Keep learning, and keep exploring the vast world of data science. Happy preprocessing!